last day we have learned to design the sequential modules, or actually what do we mean by sequential circuits, and how we can store 1 bit memory, or how the sequential modules are used as a memory. Then we have seen the construction or the design of the SR latch, the clocked latch, the D flip-flop, etc. Now, today we will continue the discussion on the sequential modules, the other different type of sequential modules that are being used in real life circuits. But before that, we will see that what do we mean by the propagation delay, setup time, hold time, and actually how these times are affecting the actual value of the at the output line. So, first we see the propagation delay, and it is defined as the time taken for any change at inputs to affect outputs. Say if we consider one D flip flop, then change on D that will affect the change on Q. Now, the time taken to propagate this effect from D to Q, we are calling that is the propagation delay. Now, setup time. The data on inputs D must be held steady for at least some time before the clock changes, so that we can get the fault free output, and this time before the clock changes, the time for which it is needed to keep steady the data inputs or the inputs at the input line, it is called the setup time. Similarly, the hold time. Hold means the previous value holds at the output line. Last day we have learned that thing. So, after the clock changes, the time needed to keep steady the input lines or the inputs at the line D is called the hold time. So, data on inputs D must be held steady for at least this time after the clock changes. Now, if we see on the last day what we have seen, the D flip flop, again that it has only one input and another inverted input, that means from the same input it is as the R, and the clock is fed at the both the AND gate, and then it is actually our SR latch, that NOR gate, two cross coupled NOR gates. So, this already we have seen last day. Now, with respect to this or the timing specifications of the D latch, if we see, then what will be the propagation delay, setup time and the hold time, that we will be checking. See, these are the timing specification. Now, first this is my input line D, this is my clock, and this is the output Q. Now, the D changes from 0 to 1. So, this is the line that this is the line when the D changes, or this is the time when D or the input changes. See, the clock changes from 0 to 1, this is the time. So, this is my clock changes. So, this should be, because the setup time we have defined that the time that when it is keep steady before the clock changes, that means the inputs, D inputs. So, this is my, this should be my T setup. So, this is my TST, that TST is my setup time. This is my setup time. Now, after the clock changes, the again input should be steady. So, here it is after the clock changes. So, this is my, this is T setup, and this should be the whole time, that means T HT. This is the whole time. Now, this is my, for the clock signal, that see the clock changes 0 to 1 and this is clock, this is 0 to 1 and this is my 1 to 0. So, this is my TW, the clock width or clock time. Now, the propagation delay, how we have defined, again if we see that how we have defined the propagation delay. See, see propagation delay we have taken the time taken for any change at inputs to affect the outputs. So, here we must see the input and the output. So, if we see now the input and the, see now the input changes at this time and the, but the output changes, So, this is my Q and this Q changes at this position. So, this is my output changes. Now, if we see that this is my 0 to 1 and that the mid position, this is my D equal to, D becomes 1. So, this is my propagation delay, that TPD, the propagation delay time. So, again if we write, this is the T setup time, this is the T hold time, and this is the propagation time, and this is my TW, the clock time. Now, if we consider the latch, then similarly that this is again D and clock, if we give that, so this is a clock latch, then similarly the here the D changes from 0 to 1, the clock changes from 0 to 1, this is the position. Here the clock changes from 1 to 0, and here the D changes from 1 to 0. Now, similarly, that when D changes from 0 to 1, here the Q changes, that means my output, the output changes from 0 to 1 is this position. So, now see for the latch that this is the input change and this is my output change, and this time difference we have defined as the propagation delay dPd, because the time taken to affect the change of inputs to the change of outputs. So, this is my this time. Now, when the clock changes, this is the time the clock changes and this is the time the output changes. So, this is again with respect to clock the propagation changes Tp, and as usual this is my setup time, that after before the clock changes, this should be the setup time and hold time. So, these are the two timings. Now, so far we have discussed the latches. So, if we summarize what we have read about the latches, that two cross coupled NOR gates form an SR latch, the set and reset latch. A clocked SR latch has an additional input that controls when settling and resetting can be taking place. A D latch has a single data input, the output is held when the clock input is a 0, the input is copied to the output when the clock input is a 1, because we have seen that when clock is 1, the D equal to, if D equal to 1, then Q equal to 1, when the clock is high. Now, the output of the clock latches is transparent. Now, we see that latches and flip-flops. So, these terms are sometimes used confusingly. So, we must clear this what is the difference between these two. See, normally a latch is not clocked, whereas a flip-flop is always clocked. So, initially when we have defined the SR latch, there was no clock, only this is a two cross coupled NOR gate was connected, and S and R, the two inputs were there. So, a clock latch can therefore equally be referred to as a flip flop. So, SR flip flop, D flip flop, we can tell now clocked SR latch is the SR flip flop, clocked D latch is the D flip flop. So, I can write that clocked latch is can be a flip flop, However, we will see that all practical flip flops are edge triggered. Another conversion is there, that normally the flip flops are used in real life circuit, they are edge triggered, and sometimes latches included and the within flip flops as a subtype. So, sometimes it is a level triggered flip flop is also called the level triggered latch. Okay. So, sometimes latches are also included within flip flops as a subtype. So, we see that it is a positive edge triggered flip flop. So, this is a normal D flip flop, this is my D input, this is a D flip flop, and this is the Q output. One clock is there, clock input, and this is a positive edge triggered. That means, when this is a edge, that means this is a 0 to 1, this is 0, this is 1. So, this becomes a positive edge trigger. That means, whenever the clock changes from 0 to 1, the clock changes 0 to 1, then only the D input is enabled and it will affect the output. Now, it is a level sensitive latch. So, this is a edge triggered and this is a level sensitive. So, again we can tell that this is here also clock is one input, but this is a level sensitive, this is not edge. Similarly, this is a D input, this is a level sensitive latch. So, this we can call the latch and this we can call a flip flop. This we can call a flip flop and this is a latch. Now, if we see the timing diagram of the flip flop and latch, see this is my input, D input. These are my clocks and this is Q, means these are the outputs. We have taken one for the flip flop, another for the latch. Now, if we see the timing diagram, then see the D changes from 0 to 1 and the clock changes slightly after that. So, only the effect will be the Q will be changing from 0 to 1 when the clock will change, not here when the D has changed from 0 to 1. Here D has changed to 0 to 1, but clock has changed slightly after that. See here. So, the output will change when it will be a 0 to 1 edge triggered, 0 to 1 the edge triggered clock, that time the output will be 1. Now, D becomes 1. So, again it becomes 1. See here D becomes 1 to 0. So, that change is shown at the output line when actually the Q is changed from 0 to 1 or 1 to 0. Here it is, again it is a 0 to 1, next case it will be there. If it is a positive edge trigger, then it is a 0 to 1. So, when it is a 0 to 1, that time only the output changes from 1 to 0. So, here it is a output changes, here the output changes 0 to 1, here the output changes 1 to 0. And see, both the times when the output changes, that at the positive edge of clock, So, this is that flip flop. So, that means this is a flip flop we can tell the flip flop is a edge triggered flip flop. Now, we see that what will happen for the latch. See, if it is a latch, that means it should be a level sensitive, not the edge. Now, again the D changes, here the D changes at this position 0 to 1, the input changes, but the clock here it is a level, this is a 1 level, this is 0 level. So, this is 1, this is 0. So, as it is a level sensitive, so the latch will, it becomes 1. So, the latch output becomes 0 to 1. Now, similarly the D becomes slightly, D becomes 1 to 0 slightly before the clock changes 0 to 1. See, here also the clock level changes 0 to 1 level. So, the first time that latch changes from 1 to 0. See, in this phase, in this position, the output of flip flop and output of the latch are same. Now, if we see that the next data input, when the data input changes from 1 to 0 and 1 to 0, now at this position, see this data becomes, data is 1, data is 1, but the latch, say as it is a level sensitive, so the when the clock becomes a 1, then only it is, see this position it is changes. That means, I can write in this way. See here this data changes from 1 to, data changes from 1 to 0 and data changes from 1 to 0, but see the it is a clock level, not the clock edge, but still the, as it is a level sensitive. So, as the level becomes 1, so the D changes. But if we see the output of the flip flop, as it is edge triggered and the edge has not changed, the clock output edge had not changed, it is becomes 1. So, the Q flip flop is not changed. So, here there is no effect. So, we consider this position and this position. These two differs in flip flop and latches. Here as edge has not changed, so that is why it is unchanged. As here edge has not changed, but level is 1. So, as D changes, that the latch output changes here. So, now clock latches are level triggered, just now what we have seen. While the clock is high, inputs and thus outputs can change. A flip flop is edge triggered either by leading or falling edge, means the positive or negative edge triggered of the clock pulse. Now, if it is a, I take one clock, so this is one clock pulse. So, here in this edge the clock becomes 0 to 1. This we are calling the leading edge. This is leading edge or positive edge trigger. Here this becomes 1 to 0. This we are calling the falling edge or negative edge triggered. Now, ideally it responds to the inputs only at a particular instant of time. Now, again if we see the RS latch, last day we have seen, again if we remember the diagram. So, it was simply 2 NOR gates, this is one R input, one S input, another input is fed back, and this is Q and Q bar. It was the. Now, if we draw the truth table, say that Q means the Qt and Qt plus 1 means, say at any instant of time t we are considering the inputs of this. So, this is at one instant of time, that this is my, these are my inputs, and this is the output. Now, both S and R 0, 0, 0, that time that state can be, present state can be 0 or 1. Now, whatever be the value, we have seen that if R and S both are 0, 0, then it should be the next state should be the present, or current state should be the previous state, or next state should be the present state. That means, this is a hold condition. So, whatever the Qt value, the Qt plus 1 value are the same, that means it is 0 and 1. Now, when S and R value is 0, 1, 0, 1, then if Qt is 0, that means that presence at tth instant of time, that Q value is 0, then output is 0. Even if it is 1, but the RS value is 0, 1, the output is 0. So, this is my reset condition. Similarly, when it is 1, 0, whatever be the value of Q, the next it will be 1, and that we are defined as the set. If it is 1, 1, whatever be the value of Q t, then it is not allowed, or lastly we have defined undetectable or unpredictable, the question given question marks, that means it is not allowed. So, already last day we have seen this is the truth table of the SR latch. Now, if this input and output, this truth table, always we can draw a Carnot map of that. So, there are 3 inputs, the S, R and Qt, and only one output Q t plus 1, say the next state. So, if it is 0, 0, 0, just we put that value. If it is 0, 0, 0, 0 or 1, actually qt value is qt plus 1. So, 0 1, this is 0 1. If it is SR is 0 1, always it should be 0 0. If it is 1 0, always it should be 1 1, and if it is 1 1, this is my cross means undefined or undetectable. So, from here, if we from the Carnot map we can derive the characteristic equation as the next state or the next output is the S plus R complement of qt, means the next state will be the R bar into the present state. So, this should be the characteristic equation of the SR latch. Now, we see another design of latch, so that we can avoid these confusing states. Now, here we have to feed the output in such a way, so that never the input or the RS values can be 1 1, because what we have seen that if the RS value becomes 1, if my R equal to 1 and S equal to 1, then only this Q becomes unpredictable, or so we want to avoid these states. We want to avoid. D flip flop is one simplest solution. Another simple solution is that JK. See, here we have taken two inputs J and K, and that is fed as the to AND gate. So, these are my J and this is my J and this is my K input. Now, here these two output of the AND gate, they are treated as the R input and the S input. So, this is now this becomes a RS latch. This is my latch. So, this is my RS latch. So, the output Q and Q bar, that what we can do, that output is fed back as the input of AND gate. So, this is one, and the other output it is fed back to the input. So, this is the simple circuit. Now, if we see the truth table of the JK latch, then it has again JK has value 0 0, 0 1, 1 0, 1 1, and for each of the cases this both when 0 0, the present state or the we can tell that at the time instant t the Q value can be 0 1. Now, whatever be the case, if it is 0 1, the Qt plus t means the next time it will be a 0 1, it is equal. So, this is a whole state. Similarly, if it is a 0 1 0 1, then always it becomes 0 0, that is a reset state. If JK value is 1 0, then whatever be the value of Q, it is a 1, so it is set. Now, we see that what is when J equal to 1 and K equal to 1. See, if J equal to 1 and K equal to 1, then if the Qt value is 0, then actually this is 1 0. That means, when Q is 0, the next Qt plus d, that next state will be 1, which is complement of Q bar. Again, when it is 1, it will be 0, that means Q bar. So, these we can see that this is a toggle, means the complement, and the characteristics equation will be that q k plus q bar j or q k plus q j. Now, if we see that the timing diagram or the timing specification or timing diagram of the JK latch, then see this is J input. So, up to this time this becomes J becomes 0 and K is also 0. So, Q becomes 0, this is 1, Q complement. Now, see that J is 1, K is 0. So, 1 0 means this is a set condition. So, Q is 1. So, this is a set. So, this we can tell this is a set condition. These two are giving a set. Now, when J is 0 and K is 1. So, that means J is 0 and K is 1. So, it will give Q equal to 0. So, this is reset. This is Q equal to 1 set, this is Q equal to 0 reset. Now, J equal to 1 and K equal to 1. So, this is the J equal to 1, K equal to 1. Now, see here what will happen, that Q becomes, because it is a feedback, so that it will be 1 0 1 0, this type of thing will happen at both the, because it is a complement of Q, the two outputs are, one is complement of other. So, both will toggle, means that it will be 1 0 0 1 1 0 1 0 1 0 1 0 like that. We define this as the race condition of JK. So, this phase, this is called the race when J equal to 1, K equal to 1. This will appear and this is called the JK race, means the output toggles. Now, this is a single state change per clocking event, and solution is another flip flop. So, again we have to modify the circuit so that at J equal to 1 and K equal to 1, this situation will never happen. That means, this J equal to this output should not be toggled, and it is a master slave flip flop. Now, we see the construction of master slave flip flop. So, first we take two RS latch. So, this is one RS latch. Now, again it has two inputs, because it is one RS latch. So, actually two JK flip flops are attached. And the clock is, see here, this is very important portion, that this is very important portion, that the clock is inverted. So, the first RS latch, the clock feeds as it is, whereas for the second latch the clock is being inverted, and for this type of flip flop, see the AND gate, it is a 3 input AND gate instead of, so this is a 3 input AND gate instead of 2 input, and the inputs are either J or K, the clock and the feedback. See, if we this is the sample inputs while clock is high, that means it will be enabled the input only when the clock becomes high. So, the first RS latch will take the input when clock is high. Now, see, when this clock is high or when the first one is taking the inputs or it is operating, then the second clock or the clock input of the second RS latch, that becomes 0 because it is inverted. And if it is 0, if the clock is 0, then we know that from the functions of RS latch that it will hold the previous state. So, here when the first RS latch is operating, that it is second one is holding the previous state. Now, what will happen in the next time? When this clock becomes negative or the clock becomes low, then it will not, the first RS latch, the input will not reach. But the second one, as it is inverted, for the second RS latch the clock input becomes high, and as the clock input becomes high, so now it will take the input from the previous RS latch. So, but the input of the second RS latch is the output of the first RS latch. So, that means the output of the first RS latch or the output of the first latch is passed to the second RS latch, and it is the output of the second one. So, means that when one is operating, another is latched, and that is why it is called the first one is called the master stage. This is a master flip flop. So, this latch is the master and this latch is the slave. So, mainly that clock input is inverted, and when one clock is high, that means one latch is being operated, the second latch is holding the previous state. So, this is the main concept of the master slave JK flip flop. Now, again if we see the timing specification, the timing diagram, of JK latch, then see that this is the J input, the first one is taken as the J input. Now, second one is K input. So, here the J is 1, or shall we take J is 1, K is 0. Now, as the clock is low, whatever be the thing, the clock is low, So, it is a set condition. Now, here when clock becomes high, this situation, this condition that j is 0 here, see, better we see here. See, this situation here j is 0, k is also 0, and that time that clock, so that clock becomes 0 to 1. So, here it is just before that the clock was 0, just before that. So, here this is the situation when j is 0, k is 0, clock is 0. So, it holds the previous one. So, what will be the value of q? See here that q becomes 1, that means this is a reset q and this is a q complement. That means that the previous output or the output of the first latch, this P first latch comes here, and again the second output of the other output, second output of the previous latch, that comes here. Now, what will happen when j equal to 1 and k equal to 1? So, just we see this condition. See here j equal to 1, k equal to 1. So, just before that clock was 0. Now, when the clock becomes 0 to 1, that means it is a edge triggered. Now, the output of the first latch becomes 1, P becomes 1. Now, Q becomes 1, Q becomes 1, and here obviously it is a complemented. So, Q equal to 0. So, see that P and P complement, these are my master outputs, and these. So, here that P equal to 1 and here Q equal to 1. Now, when P becomes 0, P becomes 0 and still Q becomes 1, and see here even the j and k are become 1, they are not changing, the inputs are not changing, but these values are changing. See, the input becomes stable, the j equal to 1 and k equal to 1, they are fixed, but still the output of the first latch, that becomes 0, 1, 0, and the slave output also, that is also that 1, 0, 1, in that way it is changing. Now, already I have mentioned that flip flop is a edge triggered device. So, that can be a positive edge triggered or it can be a negative edge triggered. So, now we see that what is the positive and negative. So, if we consider a D flip flop, then again that if it is a D, this is my D flip flop. So, D becomes 0 to 1 and this clock is 0 to 1 here, clock becomes 0 to 1 . So, clock becomes 0 to 1 here, this becomes 0 to 1 positive edge triggered. Now, then only the Q, see the output will change, the output will change. Similarly, when the clock changes from 0 to 1 here, then only the output will change. So, input sampled on rising edge and outputs change after rising edge. This has been shown here. Rising edge is the positive edge. Now, if it is a negative edge triggered, the input sampled on falling edge, say here, this is a falling edge, means here this is a clock 1 to 0, and then that for the negative, say if it is a negative, see here it is not changing. So, for negative, even it is a 0 to 1, the clock has changed here, the clock has changed here, but the negative edge it is changed, it has not changed. Again the output has not changed here, but when it is a 1 to 0, that means this is a my negative edge triggered, then the D becomes here, D is 0, and the clock, as the clock changes, so the negative edge triggered output, negative edge triggered flip flop, or the output of the negative edge triggered flip flop has been changed from 1 to 0. So, for positive edge triggered flip flop, only from 0 to, when it will be 0 to 1, the output will change. When for the negative edge triggered, if it is 1 to 0, then the output will change. Now, so far we have discussed the different type of latch and the flip flop, and now if we summarize, we see that in real life circuits, what are the different kinds of flip flops are being used to realize the large circuitry. So, first we have seen that one is that RS clocked latch. So, this is used as storage element in narrow width clocked systems, where it is narrow width means it is a, it first changes, or the memory, if it is a memory or storage, where it keeps only for a small time. So, its use is not recommended, however, fundamental building block of other flip flop types. So, just for some alarm, so it can be used. So, only for narrow width clocked it can be used. Now, the JK flip flop, it is versatile building block and can be used to implement D and T flip flop, usually requires least amount of logic to implement, but has 2 inputs with increased wiring complexity. So, because of once catching, never uses master slave JK flip flops, and this is edge triggered varieties exist. So, normal JK flip flops can be used as D flip flop and T flip flop, and that is the main use. Now, the simple D flip flop. So, it minimizes wear, because we have seen that it is the simplest kind, much preferred in VLSI technologies, because it is very efficient and takes very less hardware, simplest design technique and best choice for storage registers. That means, for 1 bit storage, this is the number 1, the D flip flop. Normally, T flip flops do not really exist. This is the some flip flops means the toggle type of flip flops, and but constructed from JK flip flops, because we have seen that JK flip flop mainly toggles and usually best choice for implementing counters. Normally for whatever be the type, we preset and clear, that means one reset and the clear inputs are highly desirable. So, whatever the flip flop implementation or whatever type of flip flop we use, that we prefer that one clear line and one reset line. So, now the today's lecture and the last day's lecture, there can be some of the quiz questions, that how one bit memory element is formed by inverter, NOR gate and NAND gate. Then second question is, what is the difference between flip flop and a latch? What are the setup time and hold time and why they are important in real life circuitry? So, these are the three quiz questions that are mainly based on the last two lectures. Okay, here we end the class. Thank you. Last day we have learned how to design the different type of flip flops, say the D flip flops, RS flip flop, the JK flip flop, and what is their problem, or what are the advantages and disadvantages of different type of flip flops. Now, today we will see how the more complex sequential circuits can be designed using the different type of flip flops. Now, these more complex sequential circuits, they contain mainly the registers and counters, shifters, mainly the storage elements. So, first we see the design of registers and counters in this lecture. Before that, we quickly see the answers of the quiz questions based on the lecture 21 and 22. Now, the first question was the how one bit memory element is formed by inverter, NOR gate, NAND gate. We have read in the last lecture that the one bit memory element that is by using inverter, one NAND gate, and if it is cascaded with another inverter, that means one NOT gate and another NOT gate.